VSEPR. It stands for Valence Shell Electron Pair Repulsion Model. It's used to predict the arrangement of atoms and molecules. VSEPR theory was developed by scientists Ronald Gillespie and Ronald Nyholm. The first thing to understand with VSEPR is how it relates to geometry. Geometry is found by considering all valence electron pairs, bonding and non-bonding, and this will help you determine the angle found between atoms that bonded to the central atom. VSEPR can also tell you about the shape of molecules. This refers to the positions of atoms in a molecule. It describes molecules in a three-dimensional way. Rule 1. Apply VSEPR when the central atom has a covalent bond with two or more atoms. Rule 2. All valence electrons are considered whether or not they're being shared in a covalent bond. Rule number 3. Remember, electron pairs repel each other and want to stay as far away from each other as they possibly can. Rule number 4. By considering all electron pairs, you can determine the geometry of the molecule. Remember, only valence shell electrons are considered. Positioning of atoms and molecules allows for them to take different shapes, like linear, angular, tetrahedral, trigonal pyramidal, and trigonal planar. In this video, I follow the CPK color coding of atoms. White is hydrogen, black is carbon, blue is nitrogen, red is oxygen, green is fluorine, and orange is boron. Carbon dioxide molecules take a shape that's similar to this sewing needle, a straight line, which is known as linear. Carbon dioxide's molecular formula is CO2. As you can see, the electrons on the left want to stay as far away as they can from the electrons on the right. This forces the molecule to form an angle of 180 degrees, and its shape becomes linear. Let's replace the carbon with a boron, and let's replace the oxygens with two fluorines. Now let's add a third fluorine. What we've just made is boron trifluoride. Its molecular formula is BF3. Its atoms want to get as far away from each other as they can, and that makes them 120 degrees apart, forming a trigonal planar shape. The four hydrogen atoms in methane are separated by 109.5 degrees, and that makes a tetrahedral shape. Methane takes this shape because it has four pairs of bonding electrons. It allows for equal separation of all atoms. The shape of an ammonia molecule is what's known as trigonal pyramid. That means its three hydrogen atoms are separated by 107 degrees. Ammonia has the same number of atoms as boron trifluoride, so you may be wondering, why doesn't it take the shape of trigonal planar? Well, the answer is that it has a non-bonding pair of electrons that take up additional space. Water. Most people know that its molecular formula is H2O. But what most people don't know is that the water molecule is actually bent at an angle, 104.5 degrees to be exact. As you probably noticed, H2O has the same number of atoms as CO2. So why doesn't it take a linear shape? The easiest way to remember this is to understand that oxygen has 6 electrons in its valence shell, while 2 of the electrons are bonded to hydrogens. It has 2 pairs that are non-bonding. Each pair forms a region in space that makes a tetrahedral shape. Goodbye.